set the limit, and we'll take you there. And so the last slide is again conceptual, but it basically says, if you look at this evolution, I created a version of this slide for Google. I was trying to be less of a PQ pitch, but just sneak back in. Original wave was just basic plumbing, create the connectivity, and it was routers and switches. Through the bubble, there was a lot of this, what we call enhanced transport, which is VPN, MPLS, content distribution, all that great stuff, SMS for like subscriber management at the edge. We think this is the next big wave, and it's going to be much bigger than just the basic connectivity. This is where this whole thing finally gets utilized, and you can finally run some applications and services on it, get users subscribers, create a revenue model which has high margins. And for that, you need some kind of a service level intelligence, not just packet level.
Third wave besides computing?
Sorry?
What companies are in this third wave besides computing?
So there's some small companies, names like Elacoya or a lot, who they focus on the enterprise or the very small providers. They have basically software, and then at some point we expect the Cisco's and Junipers to address this. And that's a slight conceptual issue because some of the carriers say we want the router, if transport is a commodity and router enables transport, then we want it to follow the laws of commodity. We want it to be half the footprint, half the power consumption, more ports. The last thing they want is to now layer a lot of software and state and tools and programmability into those devices. They just want those to be cheap and effective. And this is back to the ratio. They want to overlay the network with some amount of intelligent elements that they can manage that can deliver those capabilities.
What kind of IP domination you have in this area, in this paradigm, compared to other companies? I mean, other companies entering without you getting involved.
So in terms of the story, we were there first. I think we have a
Patents and...
Yeah, we've applied for more than 20. We've got a few that...
What about international?
Yeah. We think a pretty good head start. Others will follow, but...
I mean, how good are you in China, India, and are you proactive there?
China, Japan, Korea,
Okay.
Singapore, a lot of places in Europe, Latin America, U.S., Canada.
Sure.
We're getting to a pretty decent size of a footprint.
Okay.
And we think by then it'll be hard to displace us. Our game's going to be a software game. Those are highly programmable platforms. You can create a lot of new capabilities into your network. The box has already been installed, integrated, so it's almost a captive audience.
Are you a technology enabler or someone who goes and provides the whole solution? What stage are you in?
No, we're a small company, so we work with a lot of larger companies, system integrators, HP, IBM, Ericsson, Siemens, Alcatel.
Sure.
And for some of those very large providers, that's the only way to do it.
How long have you been a company?
4 years.
When did you go public?
Oh, come on.
I think we're off the subject here.
Yuval, thank you very much.
It was a pleasure.
I just have to tell you, it's a shame knowing remembrance of your effort. I really appreciate
Yeah,
you
this is
doing
great.
that. So, thank you very much. This is a super topic.
Yeah, very good presentation.
Yeah.
Very good presentation.
We'll have to invite you back in a little while. I don't think you got a chance to tell everything that
Right.
people. This is one of the more anticlimactic introductions I've ever had to make.
Yeah, we've already had our discussion with him. We're done.
He said, thank you. You guys left us. It's really great. I feel very retro today with my Innsbruck shirt, like I'm going to go play golf or something after the meeting here. Welcome to the November meeting of the Internet Developer Group. We'll be recording it again, and if I ever get out of some sort of operating system hell, I'll actually be able to get a real audio file up so people who prefer that way can actually get one. Till then, I'll put it up under the media file. Our speaker tonight is going to talk about something that not too many people know about. It's one of those little things in the inside of the net that they don't think about. I know I had someone who was connected through one of my servers, one of my routers, firewall routers, IP masquerades, and he kept saying, it's slowing down, it's slowing down, it's slowing down. I said, no, I think maybe you're getting too much P2P and you're getting control of what's coming down there. Oh, no, it can't be that, can't be that. I think it was, because I was seeing mail just fine. I was seeing the other things just fine. But something was going on there. And by the way, we'll bring this up in question later, but the ISP denied it was happening, but I know that I was getting stuff and he wasn't, so I suspect something on that. Our speaker this evening is Yuval Shahar. And his early experience with National Semiconductor and Motorola led him into starting some interesting things which we've had talks on, and we're maybe ready for another one too, by the way, because he was one of the early guys and VP of R&D at Vocaltech in voice over IP products, which is a coming technology. He went on from there to co-found or found InfoGear to make web appliances, and about 2 years ago we had a whole series of presentations on tablets and PDAs and other kinds of web appliances. Was a co-founder of Penacon in 1999, and from there went on to found PCube. And PCube's main job is to manage the IP traffic at the upper layers, not down at the physical layer like many people might do, but actually from anywhere from layer 3 to layer 7. So we're looking forward to hearing just exactly how we can get our hands around the hot new applications of today, according to my son, who's in the middle of this demographic. Thanks a lot.
Thank you. I have a feeling this is going to be very interactive. So what I've done is this. I've copied the code, but we'll talk about whose father's network this is and what the network is like and why it's changing and how. For a bit, about half of this. And then I'll try to address some of the more technical issues of how we deal with it, what is within the technology that will help drive some of what the network needs in order to grow up. And jump in any time. So the first few slides are a little bit of more conceptual slides, but essentially just to provide the mindset of where we're coming from. And essentially, we started with, as I said earlier, a little bit before this became fashionable, but we looked at the network and we called it just basically transport. There was a lot of fiber getting deployed. People saying at some point during the bubble that there are areas around the globe where if a meteor hit the Earth, it would bounce right back into space because there's so much fiber under the ground. So we knew there's going to be a lot of connectivity, and we said that's fine. Connectivity is like an IP dial tone. So you have the dial tone, what do you do with it? And we often said a great broadband connection to the home is like having a great state-of-the-art PC with just Windows on it. You can still have fun for a while, but the real value of having a PC is there's a lot of interesting applications you can buy and install that actually do something useful for you. And we looked at the network and we said, if that doesn't evolve, just providing commodity transport is not going to be a profitable business. And again, 4 years ago, profitable was not part of business. So, the basic business model was if you lose on every customer but make upward in volume, you can have a great IPO and be very successful. And so we started this anyway. We looked at how the connectivity will continue to evolve and came up with the concept saying we're not out there to create a better network transport device. We are assuming there are great companies building transport elements, routers, switches, aggregation boxes. And so our target was to build this intelligent overlay that would sit in the IP network and not worry about where packets need to go, but instead would worry about what applications run on the network, what users are up to, and try to use those tools to provide visibility and create some models for differentiation. Essentially what this is saying is today's network, flat fee is like an all-you-can-eat buffet. And that is okay, and we'll talk about peer-to-peer. And peer-to-peer to some extent is like, say, the local football team figuring out the local all-you-can-eat and rating it 3 times a day. At some point, that stops being a viable business. And so you have to do something about it. You have to either limit the football team or say you can eat anything on the salads, but for meat, that's a separate queue and you pay extra. The same is happening with the network. So transport is commodity, it's a flat fee, but now people are using it, abusing it, and pushing the carriers to deploy more capacity with no return, because they provide more capacity not to enable signing up new users. It's the same users that will just use more and more of it. So essentially, we said, here's where this needs to go. There's got to be some differentiation. There's got to be some ability to deliver services over this IP broadband connection that people are actually willing to pay for. And again, in the early days, we were asked, broadband is expensive. Would people pay even more to get services? And we said it's like saying a computer is really expensive. So that would people actually buy software? Yeah, without it, it's not useful. So with that, we looked at where is the network and where we think it should go. And so the first is what can the network provide? And we look at today's as a basic transport network. And it's essentially connectivity. So yeah, they talk about services, VPN as a service. MPLS, people talk about it as a service. Content delivery networks was a big thing just 2 years ago. And all those are great. We consider them to be part of transport. They're better ways, secure ways to create connectivity. When we talk about services, we mean gaming, we mean voice, we mean video, we mean all the stuff that would drive those VPN tunnels or MPLS tunnels and actually do something useful. In terms of how the network is built, philosophically, you look at transport and it's a fixed function, packet-oriented world. So to summarize transport in maybe 2 sentences, the basic function of any transport device is a packet comes in, you look at the header, headers have a fairly fixed offset. So you look at the offset that you care about, you do a table lookup, it tells you what to do with the packet. You change the packet, send it on its way, and get ready for the next packet. That's how you route, that's how you switch, that's how you do most of the basic functions that a transport network needs. We looked at services, and it's not about a fixed function anymore. It's not about single packets anymore. So if you want to look at an application session that is carried by packets, first you have to look into the payload. And the payload doesn't have this well-structured set of offsets. So you've got to have some programmability in order to be able to describe what those payloads carry. Then it's got to be some kind of a transaction-based architecture, because typically the payload doesn't hold, a single payload doesn't necessarily hold enough information. So now you have to put consecutive payloads together to look at a message. You need to track message exchanges. Yep.
Are you looking at UDP payloads and TCP payloads?
Absolutely.
So you have to store them.
Yeah, we don't have to store them, but we have to store state.
What information? Yeah, the bill of sale is time.
Right.
And that's what I meant.
Yeah. And I'll talk a little bit about how we do it.
That's what I meant. Okay.
But to some level of depth, anyway. But philosophically, we care about sessions. When a packet comes in, the equivalent description to the transport packet-oriented function. For us, a packet comes in, the first thing we do is match this packet to one of hundreds of thousands of millions of